All right, so why don't we get started? People will come in. So we're starting Unit 5, and we're going to talk about project sustainability in this unit. This will be like 5 lectures, so it's a little bit longer than the other units. And we're going to cover a host of issues. Really, we're going to start off with some open source things and then move into some things, longer term ways of thinking about projects and things like that. So when I say project lifecycle and sustainability, I'm referring to a number of things in project management that allow you to think about your project long term and give you sort of a way to meet the demands of your roadmap that we talked about earlier, but also make sure that your project doesn't fall off a cliff after 6 months because although you had maybe a successful launch, then you don't know how to maintain your project or scale it up or keep it going in the long term. So we have a number of things to concern ourselves with. We have planning, goals, which we've talked about both of those to some extent with workflows, with Kanban boards, with managing time, things like that. Communication, we've talked about that with respect to managing discussions and some of the features of Agile. We talked about cost, which is of course the triadic model where you're trying to optimize for, say, quality, and you're limited by cost or schedule and whatever. Teamwork, of course, we talked about Agile, we talked about working in small teams, distributed collaborative teams, and also teams that are hierarchically managed in large organizations. We haven't talked about control yet, but control is an important sort of aspect of this. And in fact, that's sort of what the project manager does, is that they control sort of their team. I mean, control is maybe a crass way to think about it, but they're different philosophies on this. So for example, you can have a hierarchical management structure like you have in a large corporation, or you can have like sort of a scrum master approach, which is sort of an enlightened manager, someone who can go out and motivate people and get them to do the things they need to do. And then problem solve. So we talked a little bit about innovation, and we'll talk a little bit more in the last unit in the class about innovation and how that can drive your project forward, how that can help you find a niche for your project. All these things kind of feature into the project life cycle, which is where you start your project, you work towards some initial goal, which is maybe prototyping, or it could be a design, or it could be to implement something like a product or a website or an app, first version of an app, and then to continue building, different versions, like iteratively improved versions of that artifact. And then, thinking forward several years, what are the challenges that you'll face as you grow as an organization? If your team grows, what are the consequences of that? If you choose to have an open source community and you grow that community and get them involved in the project, what are the consequences of that? What are the consequences of licensing terms? And we'll talk about a few examples of this, where this can become a problem in projects. And what maybe, how long do we want to have our project for? Maybe we only want to have a project for 3 years. A lot of grants, if you work under a grant, like a government grant, like an NIH grant or an NSF grant, it's usually 3 to 5 years. And so you have to finish your work within that period. Sometimes it's open-ended, so your project, you might have a successful project and you might continue it for 20 years. A lot of the open source projects that we talked about in the class, Linux distros, and we'll talk about Thunderbird, which is a Mozilla product. They've been doing that for decades. They keep working on it, improving the product. Sometimes it falls foul and they have to revitalize it. Well, we'll talk about all of that. And then related to that is sustainability. So sustainability is where you have, you want to keep your project relevant. You want to keep your project going. You want to make sure that you have the resources to do that. And you want to make sure that, your team is continually healthy and that you have people who could do things on a regular basis. What you don't want to do is plan to be, have a project for like 10 years and then only really have people around for 5 of those years. And then you can't do anything for the last 5 years. It may be that you decide to do some design and product release phases in the first 5 years and then maybe maintenance in the last 5 years. But in that case, you better make sure that you have an infrastructure for maintenance in place for that last 5 years. So there are a lot of issues of sustainability, and a lot of people use that term. Basically, what I mean by it is keeping things going, making sure you have the resources throughout the duration of the project so you can meet your goals. So this is, I'm often asked, I think one year when I gave this lecture, I was asked about the Open Worm Foundation and how it sort of got started and how it sort of bootstrapped itself into a foundation. So the Open Worm Foundation is an open source foundation. It's a 501c3, which we'll talk about in the next unit. But for our purposes, let's just say that they started as a group of people talking amongst themselves, saying we should do this thing. They had a project vision that they wanted to implement. So we started with people with different specialties. And you can see on the left-hand side of this diagram, with people who have different specialties, we had people interested in informatics, software development, ion channel modeling. And they were thinking about the model organism C. elegans, which is that nematode in the lower right-hand corner. And they basically wanted to build a digital model of that model organism. So C. elegans is used in a lot of biological studies and a lot of medical research to, understand processes, different types of physiological processes, different types of, organismal processes like cell growth and things like that. And the idea is that they want to build this digital model of this organism. So to do that, you need a lot of different specialties. You need to have people who know the biology and maybe know how to do computational modeling, but you also have people who maybe need to take data from other groups. And C. elegans, or the C. elegans community is very fortunate to have a lot of labs that collaborate and have the secondary data in place. So a group like this could take it and use it for a project. So they were able to, we had informatics specialists and then software developers that would be able to produce software to do the modeling. So you need to have all these specialties in place when you start the project. But it's not enough just to start the project, obviously. You start the project with people from different specialties, they have a conversation, and they have a vision, and they say, wouldn't it be nice if we could have this thing in the world? So once you have your specialists and they want to do their thing, they're able to contribute. And it's very important that they know kind of how they can contribute to getting the project off the ground, or else you may not be able to get the project off the ground. And sometimes people have these ideas and they start off by saying, wouldn't this be a great idea? And they don't have the right specialists in place. They don't have the right people in place to sort of see that vision through. And so sometimes people get tripped up for years trying to find the right people, trying to find good people to do make certain pieces of the puzzle happen. And so that could be right off the bat a barrier to the sustainability. Now let's suppose that, in this case, of course, we had our experts, they rarely work together. So let's suppose that you come up with this prototype, you come up with a nice model. It might not have everything that you wanted, but it's a nice prototype. It shows the world that you can do something. So a couple of the things that you need to sort of get off the ground, of course, are these experts, but you also need different types of things going on. So there's an arrow from that group of people, stick figures on the left, to something called artifacts. That artifact is a piece of software or a proof of concept. So sometimes if you're doing, say, like an app, or you're doing a website, or you're doing a computational model, it's usually some sort of software. But the software doesn't have to be refined. It just needs to be some proof of concept to show that you can do things that you say are going to do. And it gives people an idea of what the final product will look like. So that's very important because sometimes we don't get to that stage. We sort of say we're going to do something, we have a bunch of experts. And then we kind of say, well, we're gonna raise money, but we don't have anything to show you right now. And that's, people wanna see something, before they give you money. So that's something that's there. Then there's this advertising, there's an arrow to advertising. And this involves your vision statement. So you have a vision statement, that's the thing that originally got us off the ground, that's the thing that we talked about and said, wouldn't it be good if we had this thing in the world? Well, our vision statement, of course, gives us the artifact, but it also gives us advertising. So we can take that vision statement and that artifact and say, here is what we have. And, advertise it to people, maybe potential funders, maybe other people you want to be involved, to show them that you can do this thing. You have the vision and it's organized and it's a tight vision, but you can also do something in the world. So that's what, you have a proof of concept vision statement, which leads you to be able to advertise. And so you will first want to advertise and maybe get people involved, get more people involved, keep people involved, prove to people you can do something. But of course, that leads you to a couple of avenues of monetary benefits. So of course, you can get funding, maybe from venture capitalists or other types of sources. You can do a crowdfunding campaign. So in the case of OpenWorm, they did a lot of crowdfunding early on. And they had this proof of concept. They had this vision. It was appealing to people. And they went to a crowdfunding platform and they said, we would like to have people invest in this idea. And you get some, a sort of a trivial thing in return, but you provide us money to realize this vision. And so crowdfunding is a way to get money. Funding through venture capital is also a thing. Of course, that requires more social capital on your project's part, maybe more commercial promise. So you have to decide, if you have this proof of concept, if you have this vision statement, where is a suitable venue to try to find funding so that you can be sustainable? Is it maybe a venture capital firm? Maybe it's to go on Shark Tank. Maybe it's to go to a crowdfunding source, or maybe it's to go for grants and endowments. Sometimes organizations will have grants and endowments if you're doing something in the humanities. If you're doing something in like a nonprofit space, you can get grants and endowments, sometimes in an academic space as well, that can give you the money you need to be sustainable. So these are all options on the table. Sometimes grants will, be of a certain length of time, so you may get a 5-year grant for something. And that doesn't mean that your project has to be 5 years in length. It just means that you have money for 5 years. Sometimes you'll have to write a grant so that you can complete a certain amount of work in 5 years. You might use that grant to flesh out the proof of concept and come up with a good working piece of software, like a version 1, or maybe even a version 2 during that time. And you have to write the grant to sort of meet the requirements of the program and all of this, but it's another way to get funding. So funding is an important part of the sustainability model. And then the other thing that you can do with your proof of concept, of course, is to put it into production. So when I put my proof of concept into production, I take something that's basically a prototype. It doesn't have a lot of features. It just has it shows that this can be done. And then we work out the technical details and release a formal version. So I said underneath the software proof of concept that we have a 3D model and a Docker container. And so what those are, these are things that the OpenWorm Foundation has worked out. They first of all worked out a 3D model where they have a virtual model of the entire nematode that is, you can explore it in a browser, so you can actually take it apart. You can see different parts of the anatomy. You can do all of these things, and it's hosted in the browser. So that's one thing that was proof of concept and then later got put into production. Another thing is this Docker container. So a lot of times, if you want to distribute something, and if you remember way back to the first lecture, I talked about things that sort of define open source. One of those was something being technology neutral. And in general, you want a project to be technology neutral because you want people to be able to access it no matter what kind of hardware they're using. So if they're using like Windows or Mac or Linux or a mobile device, you want them to be able to access your project. So a Docker container is a strategy called containerization, where you can run software in a container and it basically runs, given that your computer has enough resources, it'll run with the same amount of resources on any machine that it's distributed to. So it makes things much easier to run smoothly. You don't have to worry about the technical aspects of it, the bugs and so forth. So taking that Docker container, like the 3D model, and putting that into production is another strategy. And of course, that's something you may need money for. That's something you may need more involvement, more people in the project to work on and so forth. So those are your goals. You're trying to find funding, you're trying to get things into production. You're trying to advertise your project so that people know that it exists. Sometimes you want to do that for funding. Sometimes you want to do that to get other people involved. So speaking of which, in the case of OpenWorm, we had our original people who were working on these different problems, and they're often subject experts. So they end up being like these project leaders who lead a project in informatics or an ion channel model or in software development of some type. And so what you need are new people who can do things, not necessarily in leadership roles, but people who can do like the heavy lifting. And so from that, the OpenWorm Foundation recruited people from an open source community. So people would visit the project and see the advertising or see the proof of concept software, and they say, I want to be involved in this. So they would become part of this open source community down in the middle of the diagram. And that open source community would then work on different aspects of the software, make it work. And there also would be this GitHub conduit where you manage the open source community. They would put issues up saying, maybe the project leaders would put issues up saying that these are the issues that need to be solved in order to realize the software and make the proof of concept something more rigorous, or to build new proof of concepts. And the open source community will respond in kind. And so this requires like a GitHub presence where you can open up the code and you can work on it collaboratively. It also requires something like Slack, a tool where you can manage discussions. And through that, you can sort of manage your team. But of course, sometimes you have open source contributors. Sometimes they make a casual contribution. Sometimes you make them a formal member of the team and they become important. Sometimes even becoming leaders of their own projects or, major contributors. But sometimes we want casual contributors. We want people to sort of get exposure to the project. Sometimes people don't want to become a full-time contributor. They just want to get a taste of it, or they want to gain some experience in the area of C. elegans modeling, or maybe in computational modeling in general, or maybe just in open source software. And we want to be able to motivate people in some way, give them some sort of compensation for their time. So sometimes we have casual contributors, people who just do a small amount of work. But sometimes we can get people through studentships, engage people, sometimes in the C. elegans community, sometimes in the open source software community, give them a stipend and they can work on a project and help the project, but also help themselves gain experience in open source software and building something that they can point to and put on their resume. So this is how we've gone from, in 2011, OpenWorm was sort of this idea, this vision statement. A group of project experts were assembled. They were able to bootstrap this project together and maintain it through these mechanisms. So in 2011 was sort of the beginning date, and then maybe around 2015 or 2016, there was a formal foundation that was started. And so the foundation is a 501c3, and we'll talk about that in the next unit, how that relates to finance and running the day-to-day operations of the project. So that's a little bit about starting out and sort of bootstrapping some sort of sustainable project. So this is sort of thinking about open source software and thinking about when you adopt something now, what might be the state of the art in 5 years? So when I start my project, I start with a certain set of assumptions about software, about what my options are to sort of create that proof of concept, what kinds of projects I might want to put in my technical stack or in my workflow. And so, like I said, a lot of times, if you want to minimize technical debt, you want to make very good decisions. You don't want to make a decision to adopt a technology that will basically die in 2 years or 3 years. That adds a lot of technical debt to your project, because if you want to sustain it over a longer period than that, you have to sort of migrate to a new technology, and it costs you time and money. So this is the hype cycle for open source software. This is a Gartner chart. This Gartner is an organization that does a lot of business analysis, and they create these hype cycles for different technologies. So actually, the university has access to all the Gartner hype cycle data for different fields. So if you're interested in different fields and this hype cycle, you might find one for your specific area. But this is for open source software. So how this graph works is that there on the y-axis you have expectations. And expectations are, I guess, hype. It's like, what do I think this technology will do? Right now, we're in this sort of AI hype cycle where everything is about, if I throw AI into a product, it will be instantaneously maybe fundable, maybe not usable, but fundable. So the expectations are high. It doesn't mean that the return is going to be high. It just means that the expectations are high. So we go to the x-axis, which is time. And of course, as time moves along, the expectations for certain technologies fluctuates. And so over time, we get these series of sort of modes of expectation. So the first category is this innovation trigger. That is where a new technology is born. It becomes something that's available to people. Generative AI was like that several years ago, and it became available to people through easier to use software than was previous. So it became part of it experienced this innovation trigger. So that means it gets put into the public consciousness. People are like, oh yeah, that's something I can use. So you start learning how to use it, and it becomes this thing that everyone starts doing, because there's a lot of expectation that it will become the next big thing. Then there's this peak of inflated expectations. So this is where we kind of, really have high hopes for this technology, but people are starting to sort of saturate with respect to their hopes for the technology. Their expectations saturate, and then we get to the next phase, which is the trough of disillusionment. That means that the expectations are crested and they're starting to fall, because people are realizing that they can't necessarily do what they want to do with what they have. And so there's this trough of disillusionment. This is oftentimes when people abandon certain approaches because they're not usable anymore, or they may not do what they want them to do, or the hype just may die down and people forget about it. Then the next two phases are the slope of enlightenment and the plateau of productivity, respectively. And these have to do with what happens after the hype dies down. Well, after the hype dies down, people over time eventually start to work on targeted solutions for things. And so then, over time, these technologies can actually find a place, and a very sustainable place in the world. And so this is where people become more educated about this emerging technology, which means that the expectations increase because there's specific use cases now. And then the plateau of productivity, where it's actually something that's well integrated to other products. People are actually able to use it to be productive. That's where the expectations sort of level off. You get this general expectation that it's obviously a good product. So like if you think about word processors, there was a time when word processors started, and people became aware of them, and then everyone wanted to have word processor. And there was a trough of disillusionment, and then word processors got better, and they found specific use cases, and now they're sort of at the core of office productivity. So in this case, we have all these different pieces of open source software that are at different phases in this life cycle. So we can see that in the innovation trigger phase, we have open source Gen AI code models, curated open source software catalogs, green software engineering, open source large language models, assessment practices. And if you haven't heard of some of those, that's kind of the point. They're pretty much emerging technology, so people are starting to catch on to their use, their utility, but they really don't have a good sense of what the utility is. So the expectation that they might do something interesting is high. Then you have the peak of inflated expectations, which is, like reachability analysis, source available licensing, foundation models. This is an AI thing where they build models for different knowledge domains. And internal developer portals. These are all in this peak of inflated expectations, meaning they're sort of at the height of their hype. And soon they will suffer this trough of disillusionment. So in that trough, now you have open source storage, but heading towards that trough, you have open source program offices, software supply chain security, software bills and materials, platform. And so that's heading down to that trough of disillusionment. And so now in the slope of enlightenment, we have secure coding training. And I don't see anything in the plateau of productivity here. But these charts are updated every year. So if you go back and look for the hype cycle of open source software, and you look at years past, you'll see some of these technologies at different stages in this curve. So what does this mean for sustainability? That means that, a couple of things. That means that we have to sort of think about these technologies in the framework of our roadmap. So if we want to adopt a technology, we have to understand where this technology is in terms of its general usefulness, what its true sort of utility is. And sometimes if we pick something like open source generative AI, we have to be mindful that maybe the expectations aren't what we think they are today. What may be their utility 10 years down the road may not be anything like what we think it is today. Something that's more mature, like, like something like GitHub or Git, that's probably in this plateau of productivity right now. So we know that it's what its utility is, maybe not in our specific case necessarily, but we know in general that people understand what the utility is. So we can make a good cost benefits analysis to that and figure out if it's right for our project. So this is another part of project sustainability, thinking about like the hype cycles and thinking about what to expect out of a certain technology if you adopt it, and how to think about that 5 to 10 years down. Now, I'm going to talk a little bit about success and failure. We talked about this in terms of Agile earlier. In Agile, of course, we do these retrospectives where you evaluate your sprint or your project and use at certain points and you say, what did we do well? What did we not do well? If we didn't do something well, it may not be a failure. It may just be that we overlooked something. It may be that we had a little bit of a problem, but it's easy to solve. Or it may be an out and out failure. And the same thing with your successes. Your successes can be, complete successes or partial successes. And it's really up to the team to suss that out in these retrospectives. So the retrospectives are very much a qualitative exercise where you're just trying to gauge how successful were you, how much did you fail, and how did you fail. So this results in 4 modes of work. So, like I say here, there's no such thing as abject failure. Unless you blow something up, usually that's a problem. Unless you're working on dynamite or something, that's probably bad. But most, like 99% of the time, there's no such thing as abject failure. You can learn how to overcome failure. You can learn to recoup things out of a failure, and you can use these retrospectives to frame that and to sort of figure out. But in this case, you have this evaluation of failures and successes. And failures and successes both operate in sort of two modes. The first one is an obvious mode, which is where you have obvious failures. So if you run out of money early in your project, that's an obvious failure, failure in management. You might then be able to figure out why you ran out of money. And it might turn out that you really couldn't do anything about it. It was just part of what you were doing. You also have obvious successes. So if you sell 1 million units of something in a year, that's probably an obvious success if you meet your target. Or if you exceed your target, that's an obvious success. But even within that, you have points for improvement. Then you have non-obvious failures and successes, and those are a little bit harder because you're convinced that it's either a success or a failure, so you tend not to learn anything from it. But in fact, you should learn something from it if you want to make your project sustainable, if you want to continue your project in a sustainable way. And so a non-obvious failure would be what I call a recoup fail, which is where you fail, but you can recover things from that failure and move forward on them and maybe build something successful on it. You know, it's anything from learning lessons, do things better next time, to taking something and making it a success. So you might have a prototype that you build that's a failure, it doesn't work, but there are reasons why it doesn't work. It might be that you just don't have the right design for a chip or something like that. You're not using the right material. And so you just think about why it failed, and then you can drive it forward and find a way to succeed. So that's where we have, that's where I say no such thing as an abject failure. Really, most failures, you can recoup something from them, you can learn from them and improve your project. But we also have non-obvious successes, and those are actually bad because, obviously if you have an obvious success, that's great. But you also have these ambiguous successes, which kind of lull you into a false sense of security. So if it's an ambiguous success, you know you've succeeded, but there are things in there that you might want to take lessons from. And it's not obvious what they are. So you really need to use the power of the retrospective to say, even though we succeeded, we may need to improve our process. Or we might, if we weren't in this sort of situation that we're in now, where we're running our project pretty well, we might fail. So we might be running a very tight ship and we might not experience any sort of problems from the outside world. And so we succeed and we just kind of sweep all the problems under the rug, all the brittleness of our approach, which might become apparent if we have people who aren't well trained in their area of expertise, or if you have some outside disruption like a depression, economic depression, or a pandemic. So these are things that you want to learn from. You want to learn the language of success and failure, and sometimes that isn't obvious. Okay, again, recall the role of evaluating successes and failures during the agile retrospectives, and that would give you sort of these tools to sort of evaluate your project and become sustainable with respect to those successes and failures. So now we're going to kind of turn our attention to open source software and working open. And one of the things about that is that you can create some sort of piece of software and you can make it open and you can build a community and you can build, turn out some sort of product like a version of a piece of software, and it can be successful. But you have to have this sort of culture of stewardship around open resources. Sometimes this is around the software, so you need to have maintainers, you need to have people who can fix bugs. You need to be able to deal with the day-to-day problems that occur, even when you're successful. Because if you're successful and you sell 1 million copies of the software, and there's a component of it that's open source, and there's a component of it that's closed source, you want to be able to distribute these things in a way that helps you maintain the software over the long term, helps you reach your goals. So if we turn our attention to open source communities, And we think about the software commons, which is oftentimes where you have a number of open source projects that build tools for other organizations to use. And a lot of organizations, even commercial organizations like Amazon, talk about this later in the unit, rely on open source tools. They rely on the software commons to keep their project alive. So sometimes when you're talking about a proprietary project, it kind of, sometimes it comes down to the software commons where we have open source tools that someone builds and it serves a niche and it serves a need, and other groups build on top of it. And if they don't maintain that project, if the original people in the project aren't supported, that project can atrophy and it can become a problem for all the other organizations that have adopted it. So this can, this holds true for other open source projects that rely on, like in the case of a lot of open source projects, like in data science, we use different Python toolboxes. Those Python toolboxes are usually created as an open source endeavor by some research group or by some set of programmers who want to build a tool for maybe visualizing data or doing some analysis. And so those toolboxes, Python doesn't pay people to make them. They have their own they have to build a model similar to the one I showed you earlier, where they start off with an idea and they have to build an infrastructure and they have to find funding and everything else. And if they decide that this isn't something they want to do anymore, or if they run out of people to do the work, or if they run out of money, then that tool goes away or it becomes stuck in the past. And so there are going to be a lot of projects that maybe rely on that toolbox and then need to reevaluate where they are. Sometimes they can't replace it very easily. So this open source commons, the software commons, is extremely important for a lot of our modern software sustainable infrastructure. So, we think about open source communities being an opportunity to maintain the software commons. There are many necessary components that need to be in place to make software platforms both relevant and usable. So when we think about sustainability, even if we don't have an open source software platform, still, if we're building something like software, we have to be able to make these platforms both relevant and usable. Usually that means relevance means that it has to be updated at some regular interval. So if we're interfacing with Python, we need to be on the latest version of Python. We need to have the latest functions, and we need to make sure it works fast on modern computers. We don't want to leave the software there for 10 years and then people are doing things with it and it becomes a problem in their work. We also want to make the software platform usable. And sometimes that requires user interface design. Sometimes that requires having functions that people actually find useful. Sometimes, it requires people to have access to. And if the software is written, just riddled with bugs, then it's not usable for anyone. So this is something where, project sustainability becomes important. Because if you want to have a good software platform, it has to be both relevant and usable. And that requires long-term thinking and long-term investment and long-term maintenance. Now, an open source community helps with this because you can have open source contributors who help keep platforms relevant over time as technology and social needs change. So a lot of times, if you're talking about one of these toolboxes for Python, you may have open source contributors who might even use the software as like a part of their project, and they decide to invest time in fixing or maintaining the software they rely on, which is sort of the altruistic way to view it. The non-altruistic way to view it is that they rely on a tool and then demand that the people who maintain that toolbox maintain things without giving any sort of support. And we're going to go through a number of examples of open source sort of friction in that sense, that they're going to be examples where you have very unsustainable behavior in the community and how that plays out with specific software tools. And then what does sustainable effort entail and look like in terms of effort? So again, it might be having an open source community where you have contributors who can help in maintaining some piece of software. It might be hiring a maintainer, paying them money. It might be having a team that's focused on the long term, focused on sustainability. So, you might have a version 1 of your product that comes out and it has like 4 or 5 features. And then the rest of your project will be devoted to just taking those 4 or 5 features and maintaining them. You're not going to add any more features. You're just going to take those 4 or 5 features and you're going to keep working them and refining them and perfecting them with the latest sort of standards and the latest, they keeping up with how they're used. So you might have a user base that, becomes very large, very diverse. We're using your toolbox. Maybe you develop a toolbox for signal processing and people in machine learning start using it. And it's a different community of people. So you want to be able to, maybe provide tutorials and documentation for those. So this is where your project design, if you think about it out maybe 5 or 10 years, will be affected by sort of, the sustainability imperative. So, we can think about planning projects over the long term. So if we want to have something that's sustainable, we think, okay, we can just plan out over the long term. We can have this sort of micromanaging approach where we think about our roadmap. We think out 10 years, and every 6 months, we're going to propose to sort of have this sort of change, this update to our software. And that's fine, which, is great because you can actually adapt your software to the realities of maybe 5 or 10 years from now. But you also want to think about maintaining the project over the long term. And that's harder because that doesn't necessarily show up on the roadmap. That may show up as a side branch on the roadmap. Say, okay, we're going to do some maintenance. Obviously, we'll have to do maintenance. It's not a glamorous thing, but we'll have to do it. Well, it turns out that maintenance is really maybe sometimes the whole game in terms of being sustainable 5 or 10 years out. Because it doesn't require you to reinvent the wheel. It just requires you to respond to change. So your project may be relevant 5 to 10 years from now, or it may not, in which case you may need to do some planning. But to go out 5 or 10 years, really to make your project the best project can be, you really need to have a maintenance mindset. That means keeping, what you have in your project maintained, well functioning. And that holds true for the product that you might build with software. It also includes your team, your workflows, and everything. So it's really about maintenance. Sometimes it's about planning if you have a really radical change in 5 to 10 years. But a lot of times it's just about maintenance. And getting in that maintenance mindset is important because a lot of projects don't have that. This is not glamorous work. It's just fixing things that need to be fixed, accepting things, changes that need to be made, and just checking back and taking the pulse of the project, taking the pulse of the product, and seeing how it's doing. And that's not something that most people think of. So, what we want to do is we want to respond, have like sort of a maintenance strategy, but we want to have a maintenance strategy that matches the way our organization functions. So we could have a maintenance strategy where we check in once a year and we say, well, we'll just check in once a year and make changes as they need to be made. The problem is sometimes your organization doesn't have the labor for that. And sometimes you get bursts of activity that can cause maybe a problem, maybe like a set of bugs to occur, or we have a lot of activity in the project where there's no accounting for maintenance. So if something happens during that busy time and your maintainer checks in every 6 months to a year, you can go for long stretches without catching any of these problems. And it can spell trouble for your project. So this is a piece of software that was developed where the project basically has 2 periods, or 1 period of activity, kind of 2 periods of activity, and then 1 smaller period of activity. So this project is a software project. It's functional largely through these sort of internships. And so we have these Google Summer of Code internships where people sort of find the project in February. They might contribute to the project to bolster their application. And then in April, then the selections are made for the project and the contributions fall off. Then we get actually people who are going to contribute to the project and be, actual interns. So they do their work and their work ramps up until August when the internship ends. And then there's a fallow period from August to October where no one's really contributing. And, we can think about this period from February to maybe April as sort of like this period where there's a burst of activity. And if we don't have a maintenance strategy to respond to that, then we can have problems because people are issuing pull requests and the pull requests may or may not get accepted. And they may have problems with them, but no one knows because there really isn't a maintenance presence there at that time. So we can have things that linger throughout the project for many months before it gets caught. In October, there's something called Hacktoberfest, which is where it's a thing put on by GitHub, where if you contribute to 5 or more projects, you get a T-shirt. So people are out in force during October trying to make contributions to projects. So you may get some contributions there. And again, if you don't have a maintenance strategy that matches that schedule, then you may have problems that linger. And then we don't get very many contributions until the next February. But this next February from August period, which is the following year, is shaped differently than the first period, meaning that we don't have the same pattern of contributions. So the first thing you need to do is to and you can do this with these GitHub analytics, is to look at the contribution patterns of your project, do like the GitHub repository of the project. And then you need to develop a maintenance strategy to make sure that you have maintainers in place to match these periods of bursty activity, to match these periods of down activity. In periods of down activity, you might do more intensive maintenance, such as refactoring your project. But in the periods of high contribution, you might just have someone there to accept pull requests and to scrutinize them and to make sure that they don't have any bugs. So you see that maintenance is a hard job because it requires you to sort of do an analysis on your project and then put people in place in the right places. And so, but we also not just have people contributing things or requests to the project, but we have our dependencies, which is software that we draw from that can break and it can become out of date. So dependencies are updated at variable rates. So a lot of times there are dependencies like Python toolboxes, other types of dependencies that crash, that break, that need to be updated. And so you need to have a maintenance strategy with respect to that. So really there are a lot of moving parts in maintenance. And even with a small project like this, we have a lot of thinking to do, a lot of planning. But it's maintenance, not planning, because planning is like planning on new features. And we could proliferate our features for 10 years and end up with 100 features. In lectures previous, we talked about how that's not only adds to technical debt, but is also a problem from the standpoint of, it doesn't really solve your problem. So maintenance is key in developing a good maintenance strategy. And then, of course, developing a release schedule is key. So, you want to have your releases at points where you have either right before you have burst of activity, right after your burst of activity. So you don't want to have a release in the middle of a time when you have people contributing to your repository. If you have a situation like that, you might divide your development, might develop your development scheme into 2 branches. Like we talked about in the GitHub repository, a dev branch and a prod branch. A dev branch will be where people are committing things. A prod branch will be where you're releasing things. And there'd be some lag between. But again, this is another part of maintenance where you're scheduling your releases for things, but you're keeping it separate from some of your more immediate maintenance needs. So maintenance is a very tough problem, and it's not something to overlook, and it's not also something you think is just easy. It's not just a side branch of your roadmap. So now we have a couple of examples of open source project maintenance. So, again, we have to kind of think about some of the things that happen in maintenance and when maintenance goes wrong. And so there's some very real world examples of where people don't spend enough time thinking about maintenance and it hurts not only them, but the entire community of people who use open source projects. So what happens if our source project falls out of sync with the current state of art? That can be due to lack of contributors or resources. And so a couple of years ago, there was this Apache Log4j security bug that happened in a number of open source projects. And this is where they had this bug that was exploited by malicious actors. And again, with open source projects, sometimes you don't have the resources to devote to fixing something like that. Really, what's needed here is like a meta organization to sort of help open source projects meet the needs of these security problems. But since that doesn't exist, the White House had to become involved and they were able to help these organizations overcome some of these security problems. Because remember, as I said, some of these open source projects aren't just kind of fanciful things. They're actually larger organizations that use them. And when you can get an exploit into an open source project and the open source project can't maintain, these security patches, they can't meet the challenge of security, then, it affects larger organizations as well. So speaking of this, there's this guide, our guide for unmaintained open source projects. This is from fastreview.io. This is relevant to what's going on here as well, because sometimes there are a lot of open source projects that are unmaintained or they have a lack of maintenance. It's really kind of, if you don't have a maintenance strategy, you might maintain things, but only in a patchy manner. So you don't really, if something like Log4j crops up, you can't really respond in kind. And so, they have resources for projects, sometimes that are unmaintained, sometimes that are under-maintained, and giving people tips on how to recover from that. Sometimes projects don't have the resources to be maintained properly. And so that's another problem that can occur. So project maintenance, again, is important. It can be sometimes life or death for some projects. And there are ways out of sort of this lack of maintenance, but it should never come. So Log4j, there's a link of what is Log4j. It's from IBM.com. And there's the other article, Log4j and the problem of trusting open source. So really, when you skimp on maintenance, you're not only creating problems for yourself down the road, you're also creating this lack of trust. And as we said, there's this sort of social capital that projects run on, glue that holds the teams together, but also the glue that endears these projects to users. And so one of those is trust, as you recall. And so if we can't trust our project because something like this happens, where there's this virus or this exploit that can't be easily fixed, it's going to be hard for people to trust your project. And so this is using Log4j as an example. So the Log4j vulnerability, also known as Log4Shell, is a critical vulnerability discovered in the Apache Log4 logging library in November 21. Log4Shell essentially grants hackers total control of devices running unpatched versions of Log4j. So this is a really serious issue. And so in this article, Log4j and the problem with trusting open source, they make the observation that open source isn't the issue. It's not so much that open source is either good or bad, because open sources can be very good, as we know. And really the issue isn't that you should just become proprietary, because a proprietary project can have the same problems. It's just that, you just haven't spent the time of maintenance. Companies need mechanisms to ensure the integrity of the software and the code they adopt. Sometimes this is a matter of companies auditing the dependencies that they use, find out if they're sustainable, to find out if they can handle something like this. And if they can't, can the larger organization that's adopting these tools manage something like this? And the answer is often not really, which is depressing, but that's just the way it is. There's this resource best practices for maintainers. So sometimes, if we have maintainers, if we hire a maintainer, they may need to know how to be an effective maintainer. Sometimes it's not just that you don't have the resources or you don't invest in maintenance. Sometimes you have maintainers who don't know what they're doing, don't know what to look for. And so this makes your life easier as an open source maintainer to documenting processes to leverage your community. This is one guide where they lay out some best practices, which can help you sort of manage some of these challenges better. So in the best practices for maintainers, they talk about a number of things that, maintainers should do. And, these are all common practices that improve their performance. So the first thing is documenting processes and developing community standards. They recommend that maintainers get those things out of their head and state them to the world, what their expectations are, not only to the community, but to the organization itself, to tell people what their expectations are. And it helps you avoid wasted work, and it helps you to communicate this to everyone in the team and in the public users and others alike. They also recommend that maintainers learn how to say no to avoid burnout. So maintainers who suffer burnout, as we'll see in another example, is a very critical sort of keystone to for sustainability. So when you have maintainers that are burnt out, that can create problems because people can submit things into open source repositories that are bad or they're substandard. And so we want to be able to have our maintainers be sharp at all times. We want them to be able to enforce rules, maintain the project scope, which we talked about in a previous lecture. Sometimes that's up to the maintainers to do, and maintain personal boundaries. So we don't want them to have, personal relationships with some people and impersonal relationships with others. We don't want them to play favorites. And we want to leverage the power of the community, avoid over-reliance on key people. So we want to share the workload and encourage fractional participation. So we want maintainers to be healthy and be able to, take on a certain amount of load and responsibility in the project and not burn out. And then we want their activity to be sustainable along with our project. So one of the problems with open source communities and open source projects, especially when you get a lot of forks on your open source projects, is that you're making something for a community, but the community is using it, they're forking it, but they're not giving anything back to the host project. And so this is called the maker-taker problem. Not really copacetic with the name, but this is the way they kind of phrase this in this blog post here, solving the maker-taker problem. And that is how open source projects can balance makers and takers. And this is this article here, which is from a personal blog, gives lessons from Drupal's contribution credit system and recommendations for WordPress and other open source communities. So this is where, they want to find a strategy to make sure that people who make forks of a project, sometimes you have many forks of a project, give something back to the home project. And the reason is because they're responsible for fixing these bugs, for maintaining the software for other people to use. So if the home sort of organizational GitHub can't do that, if the master fork can't do that, then the forks that rely on it can't rely on it. So there is a sustainability issue where there has to be the symbiosis instead of this sort of parasitism that you might otherwise see. So you're trying to sort of manage the way the sort of relationships between organizations. So this is where, breaking the norms of open source become a problem. And of course, the norms of open source are usually this sort of cooperative thing, and it's not really where most people just kind of take from an open source organization and use for their own means and never give anything back. This has come to a head in the WordPress fork controversy. So we'll get into what that is in a minute, but this is kind of the response in social media where, there's a set of normative standards. And WordPress, depending on who you talk to, either WordPress or their forks are sort of violating the covenant of open source. And, it's really about commercialization, but it's impacting the sustainability of the organization because, first of all, you need to have good relations between the parent, sort of source organization and the forks. But also you can't change the terms of your social contract in the middle of, in the midstream of that relationship. So, you don't want to have people fork your repository, say, oh, by the way, we're going to change our relationship with commercial licensing. That's not a good strategy for sustainability. So this is, kind of basically blasting WordPress and the person who runs WordPress. And they say at the bottom, Mullenweg, who's the person who runs WordPress, is speedrunning the destruction of the WordPress brand and eradicating over 20 years of trust. So this is a serious problem because it erodes trust and it impinges your ability to be sustained. So there is this controversy between WordPress and WP Engine. WordPress is the home organization, WP Engine is the fork. And so WordPress founder Matt Mullenweg, the WP Engine, which is a solution provider for the WordPress fork, are in this battle where they're having this dispute. WP Engine, which is the fork, started to disable core features such as the revision history as a cost-saving measure. And the criticism is that WP Engine does not contribute to the upstream organization. So WP Engine is not contributing anything to WordPress. Furthermore, WP Engine builds core features into WordPress that are being disabled. So, this can impinge a bunch of other users, maybe forks of the fork, and so forth. And so this has all been happening on the side of a specific fork. And then in retaliation, WordPress, who sometimes relies on the tools this fork is providing, has restricted fork access for all users. So there's a decision where you have a dispute between the home organization and the fork. The home organization decides that they're going to change the rules of open source, and they restrict the fork access to all users, which poisons trust in the home organization. And so, a simple dispute like this can have a widespread effect across the entire WordPress ecosystem, the home organization, all of those. So, then that poses the question, should developers rely on commercial open access problems related to WordPress, especially when their access is capricious? So when you, do something, make a decision like that in retaliation for something that you see as unfair, when you start to break that covenant, you start to get people questioning whether they should use the tool or the ecosystem at all. And so this actually has a governance angle to it, which is that single person control or benevolent dictator governance, which is the case of WordPress, can intersect with commercial conflict. And this can unravel open source functionality. So this one case is, affecting the long-term viability of a product that's already been out there for decades. But you can have one decision like this, and it can cascade into something that can destroy your project. So it's a good object lesson in how you need to maintain the open source, these sets of social relationships between open source organizations and their forks, and what maybe needs to happen to keep that sustainable. So again, solving the maker-taker problem in terms of WP Engine forking from WordPress. WP Engine profits without giving back, so they're sort of the takers in this maker-taker relationship, whereas WordPress is the maker. But in this case, that relationship is a little bit, it's a little bit put on its head because WordPress is doing things that can impinge upon the people who might give back. So there are two challenges here. There's an imbalance between major contributors and minimal contributors, and a lack of a supportive environment or users not reciprocating. And that can be both in terms of governance and in terms of maintenance. So this is, the kind of problem here that we want to avoid. So, something to think about. The last example I'll talk about is XZ backdoor and auto tools. So this was something where we had a maintainer who burnt out. We had a maintainer who wasn't supported by their project. They burnt out, they decided not to care anymore. and they were still doing their job. And as a result, they ended up accepting a bunch of pull requests that had malicious content in them. So it's basically where the maintainer overlooked package security and it hurt the organization. So there's an article on it down at the bottom. But basically, there was this contributor who was contributing code and they hid things in a software backdoor, and the maintainer not having the proper training, the proper procedures in place. In this case, they were just simply burnt out, couldn't sort of serve as the filter to that. And so not only affected XZ backdoor, but it actually affected a whole host of Linux distributions and a whole bunch of users beyond just their project. So one lesson from this is pay the maintainers or support them in different ways. You know, a lesson for projects more generally is only depend on modules that you know are definitely maintained in a sufficient way. So if you add some toolbox to your project, you want to make sure that it's well maintained. You want to make sure that it has some sort of support. When you depend on something, you should take part in maintaining it. So ideally, you should contribute something back to those organizations that you depend on. And when you build a project in an open source context, or even if you're a larger concern, a larger project where you have a proprietary component, you still, if you're taking something from an open source project, you want to make sure to be able to give back or help to maintain it in some way, help to maintain that software. So sort of the summary here is this person, and there's this cartoon, all modern digital infrastructure has this castle built of bricks. And then there's a small brick at the bottom that says, a project some random person in Nebraska has been thanklessly maintaining since 2003. And of course, the lesson is when you remove that brick, the entire castle collapses. And so the quote here from the person who was doing this maintenance and overlooked the security breach was as follows: I haven't lost interest, but my ability to care has been fairly limited, mostly due to long-term mental health issues, but also due to some other things. Recently, I worked off list a bit with GIA 10 and XZ utils, and perhaps he will have a bigger role in the future. We'll see. So this was, of course, the GIA 10 was the person who actually introduced these malicious pieces of code. So this is, you know, kind of a description down here. In the interest of time, I'm not going to go through that, but just to think about like these different examples as how sustainability can be impacted in open source projects, as well as proprietary projects using open source tools. So let me complete this section and then we'll call it a day. And we'll pick up on Wednesday. So sometimes in open source projects, we have conflict, as we've seen in examples. But you know, you have to deal with it. You can't just let it fester. You can't just call it a day if there's a conflict and say, well, I throw my hands in it. There are ways to successfully deal with open source conflict. And in fact, that's the key to sustainability, is to, you know, kind of successfully resolve that conflict and move on and learn from it. It may be a failure, it may be a partial failure, in fact, and you can learn from it. Now, it's important to realize that in open source conflict, sometimes conflict can be good. So a lot of times we like to avoid conflict whenever possible. Sometimes it's good to have conflict in a project or between two parties. Sometimes, you know, if it comes in the form of something like argumentation and adversarial design, it can be very good. You might have more engaging meetings and you might have more creative outcomes. So, you know, if you have conflict in your organization, it's not always a bad thing. Now, we saw examples of where it can be very bad. But, you know, we can have examples where conflict is wanted because you want to be able to sort of find the best solution. But conflict shouldn't be toxic. So active listening and being understanding of people's points of view is important. Sometimes this involves your forks. Sometimes this involves people on your team. Sometimes it involves people in your user base, whatever. And you want to be able to get these conflicting points of view so you can reconcile them and address them. So if you don't want to hear any criticism of your project, that's probably not a healthy thing. Good, constructive criticism is good, but sometimes, criticism can also be toxic. Knowing difference between the two is important. In terms of conflict within your team, you can diffuse some of it by referencing the code of conduct and community standards. So if you're a maintainer and you're questioning whether or not to accept some contribution, if you have good community standards, you can just simply refer to those, and that can serve as a guide. Sometimes you want to reject people because maybe suspect that they're going to harm the project. You can refer to the community standards and no harm done. A lot of times with conflict, personalities take over. So in projects, we really want to focus on the ideas instead of the personalities. We don't want to let strong personalities take over. We had an example of Robert Stallman, who in the free and open source software organization, he had a very strong personality, and he was very polarizing and basically blew up the organization. That's where a case where personalities take precedence over the ideas, and you want the opposite of that to deal successfully with. And so speaking of pull requests that are probably out of scope or maybe harmful to the project, there are strategies for kindly refusing contributions from open source contributors. Sometimes, you may do this as a proactive measure to try to keep malicious code out of your code base. Sometimes people are just wildly out of scope, or they do subpar work. And so if that's the case, then you want to be able to close the pull request without accepting it, but you don't want to gain a reputation for being unfair. So you want to be able to keep contributor workflows moving without creating a lot of ill will. And again, it's a social capital and governance issue as much as a technical issue. And so this article from the GitHub blog talks about how to kindly close pull requests without sort of violating that delicate balance that we saw with respect to the WordPress WP engine competitors. And so a couple lessons we can learn from that is close pull requests you will never accept. So if you're not going to accept a pull request, just simply close it. Close pull requests you cannot accept. So sometimes if someone's unwilling to make a change you propose, or if they're unable, then you can close that pull request. You can close pull requests on unmaintained projects. So if a project is unmaintained, you want to keep people from trying to waste their time or trying to fork an unmaintained project. And plus, you can close pull requests that turn sour. So if something is deviating from the original intent, or there's an unpleasant relationship between the contributor and the person maintaining the project, you can close the pull request. So there are different sorts of etiquette here that you need to follow. And this holds true for contributions to the project from collaborators. If you're in a proprietary project where you have a contract with someone, or they do some work for you and you have a problem with them sort of giving you what you want, or they don't want to make changes that you want, or they may try to force things on you. There's a certain etiquette to dealing with those pieces of conflict that you can learn from the open source community and how maintainers do. So the final sort of point that they make in this article is, would merging this pull request make the project better or worse for them? Not just for you in the project, but for everyone in the community. And so that's true, I think, of a lot of projects in open source, but also, if you're in an organization that's proprietary and you have a contract with someone, would kind of going through the motions and accepting a contract with someone, or, accepting a piece of work, would that be good for your project in the long term or not? And so sometimes it's not. Sometimes it's better just to say, forget about it, we're going to cancel our contract, or we're not going to accept the work that was paid for. And that's unfortunate, but sometimes that's what has to happen to serve people's long-term interests. Okay. So that's all I'm going to do for today. I'm going to pick up with this on Wednesday. And remember, last Wednesday I assigned quiz 2. So that's on GitHub. We went through that assignment. You can go to your GitHub repository and look at the instructions for quiz 2. Remember, you're going to be doing this on the main repository in the project boards, not in your fork, because it doesn't have the project board set up. So go through the instructions and try to do that assignment, and that's due in about a week and a half from now. Are there any questions before we go? Yeah. Thank you. See you Wednesday.
Thank you.
Okay.